السلام عليكم ورحمة الله وبركاته. والصلاة والسلام على سيدنا محمد صلى الله عليه وسلم. How are you, grade 9? Today, inshallah, we're gonna start our revision in physics for quarter 1. Our revision system will start with explaining some important concepts in our lesson, and then we're gonna start solving some problems or solving some sheets or our revision sheet. Not all the revision sheet, but the most important questions, or the hardest question or the difficult question that make your revision more easier, inshallah, when you try to solve it by your own. Okay, so we're gonna summarize lesson 1 with 6 concepts or 6 short notes. First one, why we study physics. Second one, the areas of physics. Third one, the scientific method, models, system, and controlled experiment. Okay, so if you remember, we started our curriculum with why we study physics, and then we said we study physics to describe the world, to describe the physical world. Okay, so what you gonna benefit from describing the world? No, you will benefit. The aim of describing, or the aim of digging and trying to describe the physical world, you will get some principles, you will get some rules, new rules, you will get many factors you can, or many ideas you don't know about the physical world or about the nature. So after describing the physical world, you will get some principles. Okay? We can say principles or rules that the physical world is controlled by these principles or is controlled by these rules by God. Okay, so by understanding these principles and rules, you can then predict what's gonna happen in the future. So the third one, to predict what's happen in the future. Okay? This was the first one. Let's get to the second one, which is very common and easy branch or easy note or easy concept in the first lesson. The areas of physics. First one, we discussed some areas or some branches called mechanics. And mechanics was associated with all of motion of any object, especially the large object, not the very small object or tiny object like sub-microscopic particles or like atoms, like nucleus. No, I mean here the large particles or the large objects like me, like cars, like fan, like pendulum, like any motion. Okay? And we don't only here study the motion, we study the causes of motion and the interaction of motions. Okay? Number 2, we're gonna study something called thermodynamics. Okay? And from the word thermo means heat. So we're gonna study anything that associated with heat energy. Okay? And you know that we measure the heat energy in any object by its temperature. If we get any thermometer and you like to know how any indicator about the thermal energy in you, so you will just measure by the thermometer, or you're gonna use the thermometer to measure your temperature, which is an indicator to your heat energy. Okay, So we're gonna mention the heat energy, we're gonna mention the engine of the car, we're gonna mention the temperature. All of these, we're gonna mention them in the thermodynamics branch. Okay? Number 3, we have branch called optics. Optics. And number 4, we have branch called electromagnetism. Okay, so for the optics study any behavior of light. Okay, but when I mention the light as light lines or straight lines, we know that if we have source of light like electric lamp, like this one, okay, this electric lamp produce or spread the light energy as a light beam, like this light beams, okay, light beams. And then these light beams strike mirror, for example, or it can also strike length, like this one, okay. So if it strike any reflected surface like the mirror, all of these light ray will reflect back like this, make reflection. And because here I'm studying the light as straight lines or the lines of the light, so I mean the optics. Here also, if I'm just like to study the phenomena of refraction, so the light pass through this lens will refract like this, will bend like this. And also this phenomena study the behavior of light as straight lines, okay? So all of the light as straight lines, we study it at the optics. And then electromagnetism, and it consists of 2 words, electro and magnetism. And I said before, electro means electricity, and magnetism very near or close to the word magnet. Okay, so for electricity, anything that you can operate with electrical energy, so we can say it's associated to the electromagnetism, like lamp, like machines, like stereo, like any machine, any AirPods, anything that's operating with electricity. Okay, and any another thing that contain magnets, so we say that also it's associated to the branch which called electromagnetism. Okay, so something contain magnet like this, like stereo. If you open any stereo, you will find a magnet inside this stereo. Or if you just like to generate electricity, you can use magnet. Or if you like to make electric winches, so this electric winches contain or use magnet, use electric magnet. So all things that associated with electricity, like charge, okay, or like machines, okay, and stereo. All of these things associated to electromagnetism, okay? And also we can mention the light here also. So light is in optics and also here in electromagnetism. But what's the difference between here and here? I said here we study the lines of the lights, or the straight lines of the light, okay, as behavior of light, okay. But here, if you just generate the light by electricity, we know that any electric lamp you can generate it by connecting it to electrical source. So when you mention that you used the electricity for generating the light, so you will say it's associated to electromagnetism. But if you describing or if you use the behavior of the light, So you will mention the optics. Okay? And number 5. Okay? Number 5, we have something called vibrations. ماشي؟ Okay? And this vibrations associated with any repetitive motion. Okay? Any motion, but this motion can repeat in equal periods of time, or even if it's not in equal periods of time, but this motion repeated motion, like the motion of what? Waves. You will find any wave like this repeat its motion. So the starting the first wave is here, then starts to repeat its motion again here to the second wave, in the second wave, and then to the third wave, it repeating its motion. Okay? Or also pendulum, if you have any pendulum. So the pendulum motion, just like this. We have here pendulum, and this pendulum start to move to the right and then to the left many times. So it repeats its motion, so it's associated to vibrations. ماشي? And very common example for this one, because we have here waves, the sound. So because of that, whenever you find any source of sound or sound, you will say it's associated to the vibrations. Okay? And it's called wave and vibration. Okay? It's wave and vibrations. Okay, so next one. So we have finished mechanics, thermodynamics, optics, electromagnetism or electromagnetic, and wave and vibration. And we still have two another branches. One of them is called relativity, and the other one is quantum mechanics. Relativity and quantum mechanics. I write them here, or right here. Okay. Branch number 6. Okay. Relativity. Okay. So, what we study in the relativity branch, we always study in the relativity the motion of very small or tiny particles. Okay? Like what? Like motion of the electrons, motion of protons, the interaction between electrons with each other, or the interaction and collision between the protons with the nucleus, interaction between electron and electron, interaction between proton and neutrons. So these very small particles, we always study their motion in the relativity. Okay, so relativity is associated with what? Motion of very small or tiny particles. Okay, like what I said, like proton, neutron, electron, and you will also explain its collision. I mean, when proton collision make a collision with nucleus, or proton make a collision with neutron. And you know, if you have proton like this one and nucleus like this one, nucleus contain protons and neutrons like this. So if collision has happened right here, so this nucleus will divided or separated, or fission, or we can sometimes nuclear fission will occur. So if nuclear fission is occur, so all of these or some of these protons release, and when these some protons release or some neutrons release from this nucleus, nuclear energy release. So because of that, if we study any nuclear energy, we will study at branch called relativity. So here also we have nuclear energy. Okay, so motion of very small particles, nuclear energy. We can say also
collision, because here happen collision between the protons and atoms, our proton and nucleus. So collision is also with us, collision. And also we have the nuclear energy, as I said. And also we have, in order to make this collision, you have to accelerate this proton. Accelerate means make its speed or its velocity higher in order to hit this nucleus and release all of this nuclear energy. So, and this process is called acceleration. Acceleration for this proton. So we can say also accelerator. Okay? And last one, number 7, which is quantum mechanics. Okay? And you have to make sure that you know the difference between mechanics, relativity, quantum mechanics. Motion of mechanics, motion of very, or we can say of the large particles or of the large objects like cars, like airplanes, like us as a person. Okay, but quantum mechanics, we said relativity, sorry, we said the motion of very small particles like protons, electrons. And quantum mechanics is also associated with the very small particles. But in this time, we don't study its motion, we study its behavior. I mean by its behavior, its place to how to measure or how to find the exact place of electron or the exact place of proton or the exact place of neutron, how it transfer from energy level to another energy level. So all of these in quantum mechanics. So we can say the behavior of submicroscopic particles. Okay, and that's it. That was all about the branches of physics. Branches of physics. So we can say we have finished half of our lesson. We have right now scientific method and models and system and controlled experiment, and these are very short part of the lesson. Okay, let's get started to the scientific method. And before I'm gonna start, I'll just check the recording of the video. Okay, it's recording. Let's get to the scientific. So whenever you like to discover something new, discover new idea, to put new solution, you should to describe, or you should to use this way in discovering this reason, or discovering this solution, or discovering this invention. You have to use this way. This way is starting well. Okay, you have, for example, any problem. So at the beginning you have to observe this problem. Observe, try to look all over this problem, to look in all the aspects of this problem. So number 1 is to make observation. And this observation is always led to question. Led to question. Okay? And then, now you know your problem. You know, you have in your mind many questions. You have problems and questions in your mind. Okay, so this observation that led to question, you need to get a solution for this question. That's right. So in order to put solution, you put something called hypothesis. Put hypothesis. So what does it mean by hypothesis? Hypothesis is the answer of this question. But is it right or wrong? It's not right or wrong, but it's reasonable answer. You put this answer or you put this solution depending on your prior knowledge about what you know about this, okay? And then you try or you check or you test this hypothesis. You put solution and you try to test this solution. So again, observation at the beginning, this observation led to question, and then you try to solve this question by putting hypothesis or putting a solution. So putting hypothesis, then you have to, this hypothesis have to be, or this hypothesis could or should to be tested. I mean, you can test this solution or you can test this answer. So put hypothesis can be tested. Okay? And how you can test this hypothesis? By experiment. Do experiment to test it. By experiment. Okay? Let's get to number 3. After you make an experiment to test the hypothesis, you will find or you will get result. So you have to interpret this result. You have to look by very detailed look to this answer or to this experiment or to this result. So interpret the result. Okay? And after interpreting this result, you will find this result is right or wrong. Okay? So, in case that this result was right, you will go to step number 4. You will make a conclusion. But if this was wrong, okay, so you have to get back to make another hypothesis. Make another hypothesis. Okay? And that was all about scientific method. How the questions is coming here, it's always coming in the arrangement of these steps. So you have to know that the first step is observation, led to question, hypothesis can be tested by experiment, then you have to interpret the result, then the result, if the result was right, you go to the conclusion, and if the result was wrong, you get back to the hypothesis. Okay? Okay, that's fine. So, that was all about scientific method, or we can call it scientific investigation. So now let's get to the models. Okay? So what is model at the beginning? Model is representation for something, representation for anything. For example, if I'm trying to make a representation for our solar system, I'll get some very tiny poles, and each pole I'll say this pole is Mars, this pole is Earth, this pole is Venus, this pole is Uranus, okay? And another huge pole, or not very huge, but larger pole for the sun, okay? So each pole is a representation for the planet. So we can say that right now the model is representation for something, okay? Representation for object or for something. Okay, this its definition is representation for something. So now, why we use models? Why we tend to use models? Because if you have, okay, if you have any representation for something, or if you have any model, you can explain on this model. Yani, as a teacher, if I get to very small students or very young students, I'll take with me my model to explain the solar system for them, to make it easier for them. So because of that, I'll say first one, to make the study easier. Okay? So let's get to number 2. By this model, you can get hypothesis. What? How I can get hypothesis by model? Okay, I'll say. Let's erase this one. Okay. Because if you have a model inside or in front of your eyes, so you may get a reason for something in your mind, or you can find any reason why this planet is revolving like this. Okay, so what if the orbit was elliptical orbit? What if the orbit was circular orbit? So many questions will come to your mind. So because of that, by the model you can make hypothesis, you can put a solution, you can get any amazing idea. خلاص? So to make hypothesis. Okay, then number 3. Also, you can predict something will happen in the future. Okay, so just like what? Like Galileo when he said that all the object is falling in the same time. Okay, but all the people in this time didn't believe in what Galileo said. So Galileo make what? Galileo just made a model for his explanation. He get rammed like this and get many poles, and he tried to release all of these poles in the same time. Okay, and the model wasn't so accurate, but he predict that in the future they will say, or they will know that all the objects are falling in the same time, but this delay because of the air resistance. Okay, so you can predict something in the future. Okay, but keep that in your mind. We can't cover all the aspect of any phenomena in our model. What I mean by that, if you make a model for solar system, so you can't explain in your model all the details about the solar system. You can't explain the motion and the size and the volume and the gases and the temperature and all of the aspect of the phenomena. No, you can only explain one or two variables or one or two parts of this aspect. So you can't make this or keep this in your mind that you can't, for number 4, you can't cover all the aspects. Okay? Okay, and this question can't cover in all aspects is getting for you many times in your question or in your revision sheet. Okay, that's fine. And before I end this point, I'll say, so because of that you have to make something called controlled experiment. So what I mean by controlled experiment, it's experiment like this one, but in this experiment you don't explain or you don't measure more than one variable. So you make all the variables constant and you only tackle or you only deal with one variable. Like what? I have here 2 poles, but I made these 2 poles in equal volume, and I made these 2 poles in the same color, and I make the ramp, the angle of ramp for the both of these poles the same angle. But only the thing that I changed it, the mass of these poles. So I have only one variable. Okay? So controlled experiment, it's experiment, okay, that measure how many values? Only one variable. Okay? Nice. So, and number 5, which is system. What I mean by system? I mean if you have
more than model or more than object in one area. Like for example, this board. Okay, this board contain wood and contain this flat board. Okay, so this is system. Okay, and this pen contain also cover and contain ink. So this is a system. So any object consists of many another small object is a system. Like solar system consists of planets, moons, sun. So this is a system. So we can say more than model or more than object in the same object to do one function is a system. Okay, so it's one or more objects work together. Okay, and that was all about lesson 1.